How much can your machine arm reach out before it loses stability? The machine becomes unstable when the center of gravity of the entire structure exceeds its tipping line. But how much is this useful when you are at early design or at machine offering stage? You don't want to search for the tipping limits by calculating center of gravity and all other forces at tens of different positions. What is the acceptable outreach of your machine with variable load on the end of the boom? Calculation models provided by InBeuro will help you calculate your rotating structure on any vehicle on stabilizers, on tracked base, or on rail track. Telescopic cranes, knuckle boom cranes, concrete pumps, aerial work platforms, fire truck extending ladders can all be described as same mathematical model of stability. Each of these machines are regulated by different standards. The standards provide individual rules for calculating tilting loads, load combinations, and required margins. Each of these machines are exposed to offset arm gravity forces, wind loads, dynamic forces due to the arm movements. In case of aerial work platform, also human forces must be taken into account. Adding them all together, we can mathematically describe each of these arms using same two figures, which are overturning moment and axial load. Now, we have a chassis with its defined center of gravity standing on its stabilizers, and we have the arm described by the moment MO in vertical plane and vertical axial force FA at the center of the slewing bearing. This is as much as we need to check whether the vehicle is still stable or not. Before we go further to details, remember to inform us in comments of what you would like to see in our next video tutorials. We would like to focus on subjects that are interesting for you. The arm and all the loads are replaced by overturning moment and axial force at the center of slewing bearing. The axial force can be displaced anywhere along the bearing axis and it doesn't change results. The overturning moment can be displaced anywhere in the working plane. We can leave it above the stabilizer just to support our imagination. The vehicle remains stable as long as the stabilizing moments are greater than overturning moments around the tipping line, which in this case goes through the pair of stabilizers. The overturning moment of the arm rotates the machine to the right. The axial load of the arm acts as a stabilizing force at radius LA, and it turns the machine to the left. Another stabilizing component is the weight of the chassis located at its center of gravity multiplied by the radius LC. Why do we ignore the reaction of stabilizers? Because they are not the primary forces, but they are results of the gravity forces, and they are not the components of the balance. What happens when we start rotating the arm by angle alpha? The overturning moment acts at different direction. Its effective component reduces by the factor of cosinus alpha. The stabilizing component of center of gravity remains the same. These are the principles. How do we use them in practice to predict the maximum outreach of the machine before it is built? You can build your Excel calculation or use the one created by InBeuro. What you are looking for is the outreach, at which the overturning moment equals the straightening moment. The straightening moment is constant, because both center of gravity of chassis and axial force on the bearing stay at constant distance from the tipping line. Differently than the overturning moment, which is a function of the outreach, and you need to teach the calculator by providing two extreme outreach states of the boom. These points should include the moment of the arm center of gravity, the dynamic factor, the wind, and moment from human forces in case of aerial platform. You don't include the moment from the lifted load, because the load is typed in separately, here. The total overturning moment, MO, consists of two components: the moment of the boom, and the moment of the lifted load. Both are function of the working outreach. The calculator builds linear function, and finds the outreach at which the overturning moment equals the straightening moment. This operation is repeated for every next 10 degrees until the calculation shows maximum working outreach all around the machine. If you still need support, do not hesitate to get in touch, or leave your message in comment. InBeuro, customized vehicle solutions. Why not subscribe to the InBeuro channel if you like it and don't want to miss our future videos?